So Matthew, if you are ready, you may start now.
Sure, sounds good. Thanks. Well, thanks for joining me, everybody, for my capstone presentation. For my capstone, I decided to create 2 time series web maps to look at water quality in 2 adjacent watersheds in Southeast Nevada. Before I get into my final products, just wanted to quickly discuss the context and motivation for why I chose this as my capstone. So as we all know, GIS is utilized in just about every profession now. It's no longer a niche field for highly trained geospatial professionals. We have multiple ways to share maps and display the information on them. And despite that, static maps tend to be the dominant form for sharing spatial information. And those work pretty well to give a single snapshot of our data. They are limited in what they can show, and I think they can overlook a broader view of that data. So I think a time series web map is an option for viewing data in a more dynamic way. Time series web map can help us see trends in the data, and they can be scaled appropriately, both spatially and temporally. They can be a lot more intuitive for the map viewer versus looking at a series of charts and descriptions of the data. So my capstone is an attempt to visualize changes in land use and water quality. The importance of that is summarized here. So the more a region is developed, the more risk there is of introducing pollutants to our waters. Urbanization increases the impervious surfaces in a watershed, carries pollutants into streams, rivers, and lakes. And agriculture produces or introduces pesticides and fertilizers to our waters. And then on top of that, wastewater and sewage can introduce a number of pollutants to our waters. These changes in land use can result in adverse effects on aquatic life, human health, and our water resources in general. So this project was an exploratory analysis of 2 adjacent watersheds in Southeast Nevada. I'll describe those in the next slide. And my final product is 2 time series web maps, or web apps, I should say, showing changes in water quality and land use over time. One of the 2 watersheds I looked at was the Las Vegas Wash watershed. And this watershed contains the Las Vegas Valley, which has tripled in population since 1990. Its current population is close to 2.3 million people. The Las Vegas Wash drains the watershed into Lake Mead at a rate of 200 million gallons a day. And the wash once had over 2,000 acres of wetlands. That's been reduced to about 200 acres by the 1990s. This was due to population increase and urbanization, which resulted in constant urban runoff and wastewater entering the wash and its tributaries. The other watershed is the Muddy Watershed, which is much less urbanized, home to less than 10,000 people. The Muddy River drains this watershed and flows through farming communities before draining into Lake Mead. Any hydrological changes are the result of the construction of aqueducts to provide surrounding communities with water. And the watershed has seen very little growth over the last few decades compared to the Las Vegas Wash. As far as my data sources, all data was retrieved from public sources. I got the water quality data from the USGS, EPA, the Las Vegas Wash Coordination Committee, and the Nevada Division of Environmental Protection. And then land use data is displayed using the USGS's National Land Cover data set. For the water quality parameters, I chose 8 that were most commonly referenced online, and I also used surface water discharge to indicate stream flow. Sorry about that. The majority of my work for this project involved reviewing and cleaning up the data, combining it into a single file for upload to ArcGIS Pro. This included removing a lot of duplicate entries, averaging data for each year, removing bad or incomplete data, and adding coordinates for each station. The available data was pretty inconsistent. It did not span all the years for both watersheds. I intended to go back about 20 years from 2000 to 2020 or so. But I ended up using the years 2000 to 2007 for the Las Vegas Wash watershed and 2000 to 2016 for the Muddy watershed. That's just how the data kind of played out. And then to get the data into ArcGIS Pro, I use the Excel the table and display XY coordinates tools. Land use is shown using the National Land Cover Dataset, which is a 30-meter resolution color map released by the U.S. Geological Survey every 2 or 3 years since 2001. And it shows 16 classes of land use. Okay, I'm going to take a look at some of the web apps created from the data. I will do a demo to showcase the functionality of them. Okay, so the first one here, this app is for the Las Vegas Wash watershed. You can see the land use categories on the map, with urbanization being a red color. The darker the red, the more urbanization. You can also view the symbology over here on the left in the legend. And then I'm going to zoom in a little bit, take a look at some of the water parameters. First one I will start with is arsenic. Make sure that's the only one going. Chloride off. Oops. Okay. So yeah, as you can see, you can turn the layers on and off in the upper right here. It's best to just show one layer at a time. So as it plays through, you can see the points increasing or decreasing based on the amount of arsenic in one area. The reason it jumps from 1 or 2 points for a year to 15 or more is not because the arsenic is increasing necessarily. It's just that's where the data was. There might have been 3 or 4 stations for 1 year, and then the next year there might have been 10 or 11 stations. And then on the left is the legend for the arsenic levels with the EPA limit, showing here at the top one. So when you're looking at the map, you can see when this large circle pops up that you've exceeded, or actually, I'm sorry, so these did not exceed the limit, but you can see based on the size of the circle, which stations are getting close in a particular year to exceeding that limit. And then you can also pause the slider and click on one of these locations and look at the information associated with it and the exact arsenic level for that year. And then for any one of these, you can also zoom in, take a look at the land use change around that point. Okay, take a look at another one here. I'll go with chloride. So in the legend, you can see that most of the chloride data has exceeded the EPA limit over the years. This EPA limit is actually the criterion continuous concentration for aquatic life. It's not only exceeded it, it's gone well above and beyond that. So that. So anyway, as this is playing, you can go up to the map layers and turn them on or off to look at the various water quality parameters. All right, so that's that one for the muddy watershed. Pretty much the same deal. You can see the land use change going on here, which is very, very minimal. You're not really going to see any change unless you zoom way in on a certain area. There's obviously a lot less urbanization here compared to the Las Vegas Wash watershed. And for these ones here, I think it was, yeah, dissolved oxygen I wanted to show. Okay, so I've started the time series. And again, you can just see the values increasing or decreasing in a certain area over time. The EPA limit for this one is actually 3.0 milligrams per liter. So this one's a little different. As the values get smaller, that's where this becomes more concerning because you're about to hit the limit for dissolved oxygen, according to the EPA. Another one here is inorganic nitrogen. So in this watershed, this water quality parameter has exceeded the EPA limit by quite a bit. The reason there's these kind of like bullseyes for some of these points, I think it's just the result of this time slider transitioning from one year to the other. So it might kind of overlap, for example, 2006 and 2007 as it's transitioning. Okay, so those are my final products, the capstone. Just a few quick discussion points that I want to point out. This project pretty much challenged all my assumptions of what was going to be happening in these watersheds. So I think what I learned from that was to follow the data and not go in with a results-oriented mindset. I thought this was all going to be showing water levels dropping and water quality decreasing dramatically due to climate change. And as I dug in, I learned a lot of the changes are really due more to land use and land cover change, and that the water quality levels were not as bad as I thought they would be. The groundwater in this region has increased over the years. And then the stream discharge has increased dramatically due to an increase in population and urbanization. So all that wastewater going into the tributaries and into the streams before it goes into Lake Mead. So it's pretty much the opposite of what I expected going in. And I kind of had to adjust accordingly as I was trying to put this together. And I also had some issues with public data. It's not as reliable as you'd hope. Very inconsistent sampling over the years, a lot of fields that are blank or not filled in correctly, duplicates. And that was easily the most time consuming part of this whole project, trying to make sense of all that data with thousands and thousands of rows of data to go through. And that is it. I'll wrap it up there, Fernando.